All right, exercise 3J. Okay, so this one we were looking at intersections. Remember in this class, if you watched the other video, I was talking about simultaneous equation of two straight lines. You're used to simultaneous equation of two straight lines allows you to find the point of intersection. In this case now, you're not finding the simultaneous equation of two straight lines. You're actually doing simultaneous equation of a quadratic equation and then a linear line. So what does that entail? It means that you can have potentially two intersections, so 1 and 2, that's 2 points of intersection, or you might have like one intersection with a parabola, so a line and a straight line, or you potentially might not have any intersections at all. Yeah, so your goal is to equate and solve. Now, the thing about intersections is when you cross a graph, when a graph crosses each other or they intersect each other, they both share the same x and y coordinates, meaning that at this point, both graphs, both the quadratic and the linear, have the same x and y coordinate. Because of that, we say that these two y values must be the same at the intersection. If they do intersect, y coordinates are the same. So because of that, for example, question 2a, we're saying if these two do intersect, then that means these two equations have the same y value. If they both have the same y value, then since y equals to x squared plus 2x minus 8, that must also equal to 2 minus x if they do intersect, because both y values are the same. So in this particular case here, you can solve it manually. You can say, all right, well, let's add x on both sides. So you get x squared plus 3x minus 8 equals to 2, and then minus 2 on both sides, and you get 0 equals to minus 10, and that's plus 3x, and that's x squared. Yeah, just in case you didn't keep up with what I just said, I said plus x because that's a minus x, so add x on both sides. But you can see 2x plus x gives you 3x, and then over here that's a positive 2, so minus 2 on both sides is the inverse. 2 minus 2 cancels out to be 0, and negative 8 minus 2 is negative 10. Okay, so now that I've got this, the nice thing is the question is, can I factorize that? Because if I can solve for x using null factor law. And conveniently, using the cross method, which I'm doing in my head, I can see that it's x and x, and it's a plus 5 minus 2. Okay, and that should give me that same equation there. So I factorize using null factor law. That means x minus 2, if it were to equal to 0, x has to be 2. Yeah, because we're saying this times this equals 0. So one of these two brackets have to equal to 0. It might have been this bracket, or it might have been this bracket, which is x plus 5. If this was to equal to 0, then what would x have to be? Clearly, x has to be negative 5 for that to be true. So what does that imply? Like after doing all this algebra, what does it mean? It just means for question 2a, y equals x squared plus 2x minus 8, and y equals 2 minus x has to intersect at these 2 points. Because I said if they do intersect, they share the same y coordinates. And I said, all right, if they share the same y coordinates, let's equate them. And let's see if they do. Let's see if there is an x coordinate where they do intersect. And it just so happens that I do have two x coordinates. So that means that if I do have x coordinates, it means there is an intersection. And intersections occur at x equals 2 and x equals negative 5. But remember, it's a coordinate. I still need to know what the y coordinate is. Okay, so all I know is they intersect at 2, but I don't know what y is. They also intersect at negative 5, but I don't know what y is. So how do I find y? Well, the equation tells you, it says, yeah, I'll tell you what y is if you tell me what x is. In my case here, it says y equals 2 minus x. So that means if x equals 2, so remember this is my value, x equals 2 and x equals negative 5. When x equals 2, then y equals 2 minus 2, 0. So that means for this coordinate, it has to be a 2, 0. And the other one is when x equals negative 5, well then y is equal to 2 minus negative 5, which is 7. So that means this coordinate is negative 5, 7. Those are my 2 points of that's how I solve for it. I get my intersections. Okay. Again, you can do this on a calculator. I showed more in depth in exercise 3K because I did start off with 3K for the video. But if you happen to be watching this, I'll show you as well. Same thing from the beginning. open up your calculator. This is from Exercise 3K, by the way. So let's have a look. One of the techniques I taught in class was I said you can do menu. Oh, just in case you didn't know, turn on your calculator. In this section here, you got your calculator button. Go down here, add a calculator. Now here, the two techniques I keep emphasizing that I recommend you to do. You go to menu, actions, one, which is defined. So menu 1 if you press that menu 1 on your calculator, you get defined. Now you want to use f of x in replacement for the letter y. So what I'm trying to say is instead of saying y equals x squared plus 2x minus 8, then now you say f of x equals 2, so f bracket x bracket, close brackets, and then equals, this is x squared, and then you got plus 2 times x minus 8. Yeah, that's what I have. Second equation I have is, I'm going to define it as g of x, because it's the second equation, so I'll call it some other letter, and I call it g instead of f. Yeah, so g of x is equal to, and this is 2 minus x. There we go. What do we want to do? We want to solve, and we equated it to solve for, and we found out x. True? So we do the same thing. We say to go to menu, 3, algebra, solve. Okay, so solve. What am I solving for? I want f of x to equal to g of x, because that's what we did. Remember, we said this is your f of x, x squared plus 2x minus 8 equals 2 minus x, which is a g of x. That's what we're doing. Solve them when both y values are the same. F of x is your y value for this equation. They have the same y value as the linear equation. So that's why f of x equals g of x. Comma, what am I solving for? X. Okay. And it solves for it for you. So x equals -5 and x equals 2. Now the benefit of defining f of x and g of x is, one, when you type this equation, you don't have to write all this. It's less hassle, right? But also, you can find the y coordinates now pretty easy. If x equals -5, you can now say sub x equals -5 into the equation. Now, instead of doing like, -5, then square it, and then plus 2 times -5, and then minus 8, like that takes too long. What you can simply do, okay, you can just say f of -5, because you're replacing the x value there. You're saying x equals -5. And it will tell you what y is. Y is 7. And that's what we had. Remember when we were solving it just now? We went down here. What's happened? There we go. -5, we got 7. And when it's f of 2, it should be 0. Now, it doesn't matter if you did f. You could have done g. But because the point of intersection, it's the same for both graphs, you could have done g -5. It will be 7 anyway. And g of 2, it will just be 0 as well. True? Okay, now what I'm trying to say is by defining it, you can just type in that. That's so much quicker to find out, rather than doing this instead of doing x squared minus 2. So instead of doing -5 squared minus, what was it again? I forgot the equation. Plus 2, sorry. Plus 2 times -5 minus 8. See, equals 7 as well, but see how long that took when I could have just typed f of -5. Yeah. Not only that, when you sketch it as well, it's also easier. So for example, if I go now Control, Documents, okay, Documents, I'm going to say Add a graph, so number 2. Now if I want to sketch this, I can do f of x, so f bracket x, because I defined it before. There we go. That's my graph. Yeah. And then I have I press tab to so you press tab and it drops down another one, and I type now g of x. And to adjust your window so you can see the whole entire intersection, you see you've got the width correct. It's from -10 to 10, but you need the height. The y value is only from -6.67 to 6.67. So we can adjust the window by going Menu, number 4, Windows, and Window Settings, number 1. So the width is good. -10 to 10 for your x-axis is okay, but your y values were too short. So we can do it -20 to 20 if we want. See, now it's so much easier to see. So it goes from -20 to 20, and you can see these are two intersections, and you can see the graph. So if I want to find now the intersection, you're going to go Menu, Analyze, and you can go to Intersection. See that? Now when you move your cursor, which on your own screen, you just move it from the if you have a look with my mouse over here, this section here, that little ball there, you can move your hand very lightly over it. It's like a touchpad, and you'll be able to move the hand left and right. Now you want it just a bit past where the intersection is. You can see the intersections here. So if you just go left of it, click it once, and then you go to the right of it and click it once. -5, 7. See, that's my intersection, and I got my coordinates. -5, 7. That's where the straight line crosses with or intersects with the parabola. True. And now I want to find this intersection here. Same thing again. Menu. Number 6 for analyze graph, and I want to do intersections. Number 4. So same thing again. I go over here, just to the left of the intersection. Click once. To the right of the intersection. Click twice, or the second time. Okay, and it's 2, 0, and that's exactly what we got when we were solving for it manually. 2, 0, and -5, 7. Same thing. Okay, and you can do that on your calculator. And I want you to be able to do calculator and by hand. Okay. All right, and you can do it for all of these ones. So every one of these you could do. So you can just go back. So let's say I want to do 4a. I'm just going to clear history here. 4a, you got x squared minus 6x. So I can say define f of x equals x squared minus 6 times x. Okay, that's done. And I can do define g of x equals to 8 plus x. Done. And what do I want to do? I want to solve for f of x to equal to g of x. I want the y values to be the same at the intersection. And I want you to find if there is an x coordinate. Oh, yes, there is. -1 and 8. Okay. And if you want to find the y values, how do you do it? F of -1. There you go. And f of 8. But it doesn't matter if you did f or not. You can do g of -1. It'll be the same. G of 8. Because it's a point of intersection, they both share the same coordinates. If you want to look at the graph, there we go, this is the graph. Okay, because I already defined it just before, so it changes the graph in this page here for you already. So that's my new graph. That's the graph has gone across. And you want to find the intersection graphically again, menu 6, analyze, and you go to intersection. And left it and right. See, -1, 7. And that's what I got. See, when x is -1, y is 7. True. Okay, so you can do it on a calculator just like that, but you also need to be able to do it by hand. So I'll do it by hand as well. So have a look. For a, you got y equals x squared minus 6x, and you got y equals 8 plus x. So what I'll do is I equate them. So I've got x squared minus 6x has to equal to 8 plus x. Minus x on both sides, so I get x squared minus 7x is equal to 8. Minus 8 on both sides, I get x squared minus 7x minus 8 equals 0. And then from here, okay, factorize that if I can. So let's see if I can. Using cross method, it should be -8 plus 1. There you go. So using null factor law, x has to equal -1 and x equals to 8. True? Okay. And then how do you know what the y coordinate is? Same thing again. Remember, you had your linear equation and quadratic. They'll tell you what y is if you tell them what x is. And I can see already if I sub -1 into where x is, 8 minus 1, 7. If I sub 8 in, 8 plus 8 is 16. So where's 16? So 8 and 16. So this is -1, 7, and this is 8 and 16. Okay, and that's exactly what I got as well. Yeah, -1, 7, 8, 16. Okay, or graphically, -1, 7, and you can find out the next one, analyze, intersection, there you go, 8, 16. Okay, same thing. Cool. All right, so that's how you do the basic questions. Now, let's go on to something a bit trickier. So let's have a look at these type of questions. I'm going to let's do, maybe we do 8. Should we do 8? Yeah, we'll do 8. We'll do question 8. Okay, we'll do question 8 together. So same thing. Difference now is instead of having all the values given to you, you got an unknown, you got a b. We don't know what b is. Okay, so let's have a look at it. We got find the value of b such that the line with equation y equals -x is tangent to the parabola with equation. Now tangent means that it touches once. It touches once. That's what we call a tangent. Okay, so that means it intersects once. Now, in order for it to intersect, as we said, the y coordinates have to be the same. So this y has to equal to this y. So if you actually solve for it now, you would say, oh, well, that means negative x has to equal to x squared plus x plus b. True? Okay? Because we're saying they have to intersect, right? But remember, not only do they have to intersect, they have to intersect only once. Now let's just try to solve this first. Let's just try to solve this. We've got minus x, so I'm going to say add x on both sides, and that cancels out. And you get 0 is equal to x squared plus 2x plus b. The problem here is I don't know what b is, so I can't factorize it. Whereas if I knew what b was, maybe I could factorize and solve. So the problem is b. I don't know what b is. But that's what the question is asking. They want you to find what b should be to make sure you only get one intersection. I don't want two. I don't want none. I just want one. So what should b be? Okay. Now this should remind you, if you're trying to solve for x here, remember you only want one answer. You only want one answer. This goes back to your discriminants. Okay, remember the discriminant? Discriminant, if it was equal to 0, you get one solution. Whereas if you get discriminant greater than 0, you get two solutions. And when discriminant is less than 0, you get no solutions. True? So this is what we're focused on. We just need to find discriminant to get one solution because that's what we want. We only want one intersection. We only want one x answer. We don't want two. We only want one. Yeah, unlike the other ones, we always get two. We got x equals -1, x equals 8. That's two x intercepts. I mean, not two x coordinate intersections. That's x equals 2 and x equals -5. We don't want two. We want only one. So to ensure that, I need to make sure the discriminant equals to 0 to get one solution. So how do you find the discriminant? Remember, b squared minus 4 times a times c. And in our case, b is your 2, so that's 2 squared minus 4 times a, which is 1, because we don't write the number, but it's actually 1x squared. And c, which is b. This gives us the discriminant, and this gives me now 4 minus 4b is equal to discriminant. But remember, what do we want? We want discriminant to equal to 0 to make sure we only get one answer. So that means if this was 0, what should b be? So you got 4 minus 4b. And you can see add 4b on both sides. So if I just went, so that's minus 4b, I can say plus 4b. Plus 4b. That's okay. Negative 4 of these b's plus 4 of these b's will cancel out. And you get 4b equals to 4. Divide both sides by 4 because this is times. And b equals to 4 and 4, which is 1. So that means that if I want only one intersection, b has to be 1. That means this equation has to be 1. Okay, so if I have 1 in this equation, then I know y equals -x and y equals to x squared, what was it again? Plus x plus 1. Was it 1? Yeah, plus 1. These two should intersect only once. Let's prove that. Let's check if this is true. Okay, so let's check if this is true. So I'm going to clear this again. I'm going to define f of x equals 2. We have -x, okay? -x. Define g of x equals 2 x squared plus x plus 1. So according to what I've solved, what I figured out is that it should only have one x value. So let's check it. Solve f of x equals g of x, comma, x. Yeah, so I want the y values to equal to each other, solve for x, and it has to only have one answer. Let's check if it does. Oh, it does. It only has x equals -1. See, it doesn't have 2. Unlike before, I had 2, yeah? But if you look at the graph now, let's have a look at the graph. Bam, see, look at that. You only got one intersection. It wasn't by coincidence. It wasn't luck. It wasn't guess check. We figured it out. Okay, and how did we figure it out? It's because we wanted one solution by doing the discriminant. Discriminant allows you to find out how many answers in this particular quadratic equation here will have to be if you're trying to find b. Okay, if you wanted 2, then you could use this. Okay, this is why exercise 3I was so important. And I did a lot of questions in for exercise 3I. Watch the videos, learn how to use them. Yeah, but that's how you do this question. So B has to equal to 1 for question 8. I've hoped that, you know, I'm sort of making you feel a bit more comfortable with your calculator work. It is essential for you to use it, especially in your exam mid-year. So do practice it. 3J, 3K, 3L are fantastic questions or exercise for you to practice. So do learn to use it, you know, like as you're doing it, do manual and do calculator work. That's the key. Okay, so I'll stop there. I'll stop there so you can not watch me talk all day.